Right, here we have the problem now, the sampling problem, and we're talking about confidence intervals. The big thing to pay attention to here is whether we use the Z statistic or the T statistic. The confidence interval equation is pretty straightforward. The spot, here we go. We have the spot estimate here. X bar applies in both cases. The problem gave us the value 8%. So the basic equation is value, spot value, plus or minus the reliability value times the standard error. Spot value, reliability factor, plus or minus standard error, sigma over square root of n. We don't know anything about the population distribution. We don't know the variance, but because the sample is large, 80, n equal 80, large sample, we can lean on the central limit theorem, which says that if we use large samples, the sample distribution is approximately normal. So we have leaned on it for the first one. So we use the Z statistic. So we were given X bar 8%, Z alpha over 2. Remember the notes that were sent to you. The alpha over 2 is because the form of this equation is really interested in the excess, what is above the right end. So although it's a 90% confidence in a 90% we're looking for, 90% just tells you what is under the curve within the limits, and 10% is outside those limits. But half of that 10% is high and half is low. So since the Z statistic is interested in the right end, that's why we use alpha over 2, so 10 over 2.05. And so our equation then set out here, values put in, this 1.65, you check your Z tables and you would see that Z for 0.05 is 1.65. We were given the standard deviation, 0.3. N is 80 and the square root of that is 8.94. So the problem is set out here, solved here. So our confidence interval, the percentage values which bracket the mean, 8 plus or minus 0.065. This is what this part works out to be. And so when we actually do the subtraction from 8, we get this as the lower end. And when we do the addition to 8, we get this at the upper end. So the confidence interval is in fact 7.94 to 8.056. And this interval, we are 90% certain, contains the true population mean. For the second problem, this one reflects, as you can see, the only difference between them is the T statistic is used here instead of the Z statistic. The T statistic is theoretically the correct one because we really don't know the variance of the population. And so in those conditions, the T statistic is theoretically correct. But because we use large samples, 80, we could make a case for using the Z statistic. But when we use the T statistic, the form of the equation is exactly the same except for the presence of T here instead of Z. Now, degrees of freedom, n minus 1 leads us to 79. But your tables probably don't have 79, so we use 80 instead. And so we set out the problem, same 8 for X bar. Now our T statistic for 0.05 gives us 1.664, which as you can see is quite similar to 1.65 here for the Z statistic. The standard error is unchanged. And so the confidence interval using the t statistic is very similar, very, very similar in this particular case. Thank you.